Hi, in this lesson, we're going to look at casting. We know that doubles and ints can be involved in arithmetic expressions. If a double and an int are involved in the same expression, the result is always going to be a double. But what if we want the outcome to be an int? We can actually change the data type of a value through the process of casting. Casting is turning something of one type into another type. Casting is done by adding the type that you want in between parentheses to cast to that type. If we try to assign the value of the double x to the int of y, there will be an error, as the int type is not compatible with the data type double that y is being assigned. But if we cast the value of x to an int, then the value of y will now be 10 without any error or complications. Interestingly, the same doesn't apply when attempting to do the same from double to int. This is referred to as implicit casting. Implicit casting is when Java automatically casts the value correctly without the programmer needing to do so. Java will cast an int to a double, but will not cast a double to an int value. Casting is especially important when considering how numerical values can change during division. In this example, we are attempting to figure out how many dollars we are able to give each person. Because the two values, dollars and num people, are ints, the dollars per person value will be truncated to equal 2. If we are looking to figure out the exact number of dollars per person, this calculation will not provide the correct answer. If we cast one of the variables, dollars or num people, as a double, the value of dollars per person will be correctly evaluated. In this case, dollars will be transformed to 100.0, which, when divided by 40, will equate to 2.5. We can also use casting to help round double values to the closest integer value. We can do that by using the expression int x plus 0.5. This works because any decimal value at 2.5 or higher will become a value of 3.0 or higher, and any value below 2.5 will still remain a 2.5 and higher value. Because ints round down, the value of the y in this case will always be the correct rounded value. The same strategy for rounding positive numbers can be used to round negative numbers. In this case, the expression is int x minus 0.5, so that the 0.5 value is decreasing the value of x. As we begin to explore numerical values in greater depth, it's important to know about the existing range of variables. As discussed in lesson 1.2, when we assign a value to a variable, we are actually associating that variable with binary data. Computers store all data in binary and associate that variable with the binary data associated with the value that has been assigned. While char values are represented by a series of 8 zeros and ones, int values are represented by 32. Each box of 0 and 1s is referred to as a bit. A single bit can store a single 0 or 1 value. Since ints are represented by 32 bits, the total possible combination of different values that can exist is more than 4 billion. Although our number system is technically infinite, the fact that int values have a finite number of storage values means that the number system in Java is constrained. Because of this constraint, there are limited amount of numbers we can use when programming in Java. So what numbers should be used? A simple solution could be to use the numbers from 1 all the way to that 4 billion value. But in doing so, we would be limiting our ability to use negative numbers for any int calculations. Thus, the number range that exists in Java splits the range across the positive and negative numbers. Because the range of possible numbers is predetermined in Java, there are preset values that we can use to represent the maximum and minimum number values. Integer.min value is equivalent to this negative 2 billion value, and integer.max value holds that value of the positive 2 billion value. These can be used to assign variables to the max and min possible values. Because the number system is limited by a storage constraint, the value is wrapped and proceeds back to the max value. This is called overflow. It's important to note that overflow doesn't always act as intended and can create unexpected results. To demonstrate the nature of overflow, if we were to add integer.minValue to integer.minValue, which is the same as subtracting the value of min value, the resulting output would be 0. Now that you've learned about casting, it's your time to try it in the editor.